Hello everyone, February 15th. All right, let's do this. Construct the lexicographically largest valid sequence. Given n, find a sequence that satisfies all of the following. The integer 1 occurs once in the sequence. Each integer between 2 and n occurs twice in the sequence. For every integer I between 2 and n, the distance between the two occurrences of I is exactly I. The distance between two numbers of the sequence ai and aj is the absolute difference between their indices. Return the lexicographically largest sequence. It is guaranteed that under the given constraint there is always a solution. The sequence A is lexicographically largest if at a position you have a bigger value. Okay, so 1 occurs exactly once, but everybody else occurs twice, and their occurrence, so 2 will have, so like 2 must have 0, 1, 2, like if it's 0 position, 1 and has to be 2 position, right? And 3 must be 2, 3, 4. 3 must have like this because it has to have, oh, my bad, must have 3 in between. And 1 can occur once. Okay. So, of course, if we want n equal to 3, so we want largest at the front, right? And it has to be 1, 2, like 3 minus 1 in between. So it has to be like this. That's 3. And for 2, we can say, okay, what if I have 2 here? If I have 2 here, then I need to have 2 here because it has to be like that, but it's already occupied by 3. So that is not possible, right? If I put 3 in, I have to put 3 here, which means 3 must be here. And if 3 must be here, then 2 cannot be here, because if 2 must be here, it's already occupied, so 2 has to move 1 step down, which means this position has to be 1. And now we do 5. So we say 5 is here, so we have 1, 2, 3, 4. That's 5. And for 4, if I want to put 4 here, then I need 3 in between, so 4 must be here. So that means it's always not possible to put the second biggest one right here. So the second biggest one must be here, which means 4 falling here. And then next is 3. Now 3 can put in here because 3 requires 2 in between, so I can do 3 and 3. But now I have to do 2, but I cannot put 2 here because if I put 2 here, 2 has to be here. I cannot do, which means 2 has to be, then there's no way to put 2 because 2 has to have somebody in between, but there's no way I can put somebody in between. Oh, that means this strategy does not work. Okay. Interesting. I figure there might be some DP going on, right? Okay, let's go back to the 5 scenario. If I have 5, I have 1, 2, 3, 4 in between, right? I need to fill out. I know the total number, right? Because we have 2 4s, have 2 3s, 2 2s, and 1 1, right? And how are we going to make it work? Well, I know 3, right? Let's say I have 3. Hold on. Let's do it this way. If n equal to 1, then just 1. If n equal to 2, right, then I have 2 and 2 because it had to be in something between. Now we'll put a 1 in there. If n equal to 3, I have 3 something something 3, right? 2 has to be here, and 1 has to be here. I'm trying to see if there's any pattern in this. So 4, right? 4 have 1, 2, 3, so 4 will be here. So I go 1, 2, 3, 4, right? And then of course I can now do 3 here, so I can try 3 here. So I have 2, so 3 will be here, right? And then I have 2 and then 2. So it'll be like this, 3, 3, and 1. Not sure if that's correct, but let's take a shot. Easiest is to go through this to see if there's any examples. 2 is, yeah, 3, we have 4. Yes, that's exactly right. I'm trying to see if there's any patterns that we can learn. 5 already have, we have 5 here, and we have 5, 1, right? We have 1, 2, 3, 4, 5. Right, it's a pyramid, right? It's a pyramid. Okay, let me rewrite this. I think maybe rewrite this will give us a better idea. When do it right, so we'll have 1, 2, 1, 2, right? 3, 1, 2, 3, 2, 4, 2, 3, 2, 4, 3, 1. 5, 3, 1, 4, 3, 5, 2, 4, 2. All right. So far the only pattern that I can see is this one will definitely go down. Right, next one will be 6, and then this one will also be 6. Right, so this column and this one will always be right, and then in between 1, 2, 3, 4, 1, 2, 3, 4, 5, right? And then we have some extra. We have 1, 2, 3, 4, 5 here, 1, 2, 3, 4 here. Now for the remaining, it's hard to see because like I don't see any obvious trend happening. I mean, we can say we've put the 6, so now we want to put the 5, right? We want to put a 5, or you can say we have 5, now we want to put a 4, or we have 3, we have 4, now we want to need to put 3, but it doesn't really work that way because I have 3 and I want to put 2, but I have to completely rearrange the 2 in order to put 3. Now I have 4. So I try to put 3 in here, but again, I have to reinvent the 3 because this just doesn't work the original way. Huh. And I have 5, but a 4 also doesn't work. Like 4 is completely different. Now there is something interesting, like 3 I go to 1, 4 I go to 2, 5 I go to 3. Does that mean 6 will go to 4? I am not very sure, but definitely 5 cannot be here, right? 5 will be conflict, so basically we'll move, like 5 will, like 4, basically I cannot do here, so 4 supposed to be here, but now I have to move it 1 more, because if 4 is here, then we just, it does not work, because 4 will be occupying this position, then 2 will not work, right? Got me, man. What is this? Or we can say, you know, like I have 4 ready. Like this is the maximum. So I try to put 5 into it. And I definitely want to put 5 at the beginning, right? And I need to put 5 here. So 4 need to make change. And I cannot move forward, so I can try to move 4 backwards, right? And if I move 4 backwards, then everything need to go backwards, right? If I move 4 backwards, then 2 has to be moved backward. But this position is already taken, right? This position is already taken. 4 can only move backwards. So, but if 4 move 2 place backwards, which means now 3 has to move 2 place, and then this 3 actually move out. Like 1 is also move out. You move 1, like this 1 is also move out. It's out of the position. Well, actually no, so 1 can move out once, but we know that doesn't work because now we create an empty space here, which cannot be filled. Oh, we also have an empty space here. So what if I have 2 empty space, right? Because I have 5 here, and I move the 4th to the right, then I'll create. Now I will have 1 empty space, which nobody can fill. And then if I move again, now 1 is out, right? So now I have. So I move once, I have 1 empty space. I move twice. Now I have 2 empty spaces, right? So basically, I say if I move once, and I have 4, 2, 3, 2, which this is also 5, and 4, 3, 1, and then we have a conflict, and then 2 can now move here, right? So it doesn't work. So I move 1 more time. Now when I move 1 more time, basically we have 5 something something 4, 2, 3, 2, 4, 3. Now 1 is free. This is 5. So 1 can fit any position. That's fine. But this 3, it doesn't work, right? And this 3 is at the end. So now what we're saying is it possible to move? Because 1 can put in here. So basically I need to move another number. Can I move 3 here? I cannot move 3 here because the other 3 is here. But if I keep moving this way, but at the end it is this way, right? So at the end, what happens is 3 moved here. So like this 3 moved forward. This 3 moved. I don't know. I don't know. No clue. I think I'm not thinking about it right. Maybe I don't know. Is this really I feel like I cannot use the solution from the previous round, and that's really bugging me. Right? Then we need 1, 2, 3. So we know 4 cannot be here. So we can try it. Next is 3. Right? And I can try 3. Because if 4 is here, it doesn't work. But if it's 3 is here, then we can have 3. Okay? So now, can we have 4 here? So I can say if I have 4 here, 1, 2, 3. So I have 4 here. Okay? Then I can have 2. I cannot have 2 here. I can have 1. Then I have 2 here, then I have to go outside. So this is not possible. So you're telling me this is just backtracking? Maybe it is really just backtracking because this doesn't work because the current option is this 4, right? So I say, okay, if we go back, then we don't do this 4 here. We move the 4 because this is the next position, right? Move 4 here, 1, 2, 3. So we get 4 here. Now this position, next open position, and I need to try to do 2, but I cannot do 2 because this position is already occupied. So I can only do 1. Then I can fill 2 and 2. Yeah, I feel like this probably is just a backtracking. We can try a 6, just kind of see how this whole thing works. So for 6, right? Once I set it up, then I say I want to do 5. The next biggest one is 5. And I say, okay, 5 doesn't work. So the next biggest one. So how do you decide what's the next one that will work? So I try 5, right? Because this is the next biggest one. But 5 doesn't work. Maybe I need a... I'll keep it sorted. 5 doesn't work. The next biggest one is 4. So I try 4 here. And then 1, 2, 3. So I set 4 here. All right, next round. I have 5 again. So I set 5 here. 1, 2, 3, 4. So I have 5 here. Okay, next round is 3. The biggest is 3. So I set 3 here. 1, 2. Doesn't work. And we're gonna try 2. Doesn't work. Now we try 1. Right? And then next is 3. Doesn't work. 2 doesn't work. So this scenario doesn't work. Okay, so basically this one doesn't work. And because I already tried all of them, so it's this 5 doesn't work. Right? So backtracking here, so if 5 doesn't work, the next biggest one is 3. So 3 doesn't work. So now I try 2. 2 works here. Okay, now I try 3. No, now I try 5. So basically each position I try all possible combinations. Right now I'll try 5 here. 1, 2, 3, 4. So I have 5. So next is 3. I can try 3. 3. And then last one 1. Then that's it. That's the answer. I am not sure. I'm really not sure if there's any pattern that we can just borrow. I mean, looking at this, I have this range of 1, 2, 3, 4. I have this range of 3. That's a 3, 2, 4, 5. That doesn't mean anything, right? I guess we just do it. I mean, I don't know. I mean, what's the runtime's gonna be in this situation? But maybe this one is just trying to, I don't know, test our ability to do backtracking. Maybe it's just backtracking, you know? I mean, it's a medium question, so it is not unreasonable that we need to do backtracking. We know the total length of this. It's going to be, I'll say, n minus 1 times 2 plus 1. So it's 2 times n minus 1, right? That's the size. And I'm pretty sure I need a function called backtrack, which is going to be void, right? Backtrack. What do we need? I need an easy way to keep track, and C++, I believe, have something called sorted set. or sorted list. Does it have sorted list? Sorted container. Is that sorted set? Set. They are all sorted using list. So I can use a set. Okay, I can use a set. And if I use a set, I can iterate through the set, I believe. I mean, priority queue, we only need 2. But if it's a set, you also need 2. Because I need to remove. So maybe it can be, I don't know, what would be the best way to do this? I mean, n is only 20, right? N is only 20. You might as well just use a set to keep track of what you have found, what you have done already. And yes, you use not even a set. It can just be an array to decide which one has been done already, and each time you just search from the top end and down and find the first one you haven't used. That actually sounds like a good idea. All right, I think that is a good idea, which means I need another vector. Right, I need another vector. We can say scene, which decides n+1, honestly. Okay, so now we have a backtrack, which we need, of course, the result. We also need a scene, right? What else do we need? We need, that is honestly all we need, or do we need something else? I mean, we can pass the leftmost index, right? The leftmost index. Or we just search through every single time. Let me see. So each time when we hit the next round of backtracking, we just we can reduce some of the repeated moves. So let's just put an index. Okay, let's just put an index. All right, I feel like this is enough. So we have an index. We have what has been seen. We need n, but n can be acquired. I just pass n into it, just for the sake of simplicity. Right, I'll pass n into it. So we need to first decide what is the current, because it's a backtracking, right? So we say for candidate c equal to n, c is large equal to 1, and c minus minus, right? If scene c, ooh-wee, I don't think this is an int. I think this is a Boolean value, right? It should be a Boolean because it's just a true or false. So if has not seen, right? That means it's a good one. Then we'll try it, right? We'll try it. How do we try it? So we'll say if it's not seen the C, and because I know that the index position is good, then I need to go the next, find the next one. So it shall be res index plus C minus 1, because if it's a 5, I need to do 0 plus 5 minus 4, right? 0, 1, 2, 3, 4. That is not true, actually. It should be 5, right? 0, 1, 2, 3, 4, 5. So whenever we hit this index, and then we need to add 3. 0, this is 1. 1 plus 3 is 4. 0, 1, 2, 3, 4. Yes. So we just add the C. If it's not seen and it is equal to 0, right, which means this position has not been taken yet, then we can try. We say seen c equal to true. We say we have seen it, and we say res index plus c will equal to c, and of course we need to say res index is equal to c as well. So once we're done, we need to walk down and find the first index that's not, right? Then we say int I equal to index plus 1, and while res I is not equal to 0, I plus plus, and I has to be smaller than res dot size, and this, right? So we'll go, and if I is smaller than res dot size, which means we find an I, then we simply call backtrack I, right? And then, oopsie doopsie, let's just redo this, res scene n, okay? We'll do this, yeah. When do we know it's good? Well, because at the end, when it's good, is I set the res, right? And then the last one to fill is always going to be 1, right? The last one's going to be filled. It's always going to be 1. So we had 1 and index 2. So yeah, we need an endpoint. We need an endpoint, and we need this one to return true or false. That's true. We need to return true or false. Otherwise, we don't know if it's successful, right? So, and if it's smaller than, then we can try the backtrack. And if the backtrack, like if, okay, so if it's smaller, right? If it's bigger, then else we just don't do anything and we will cancel it. So this is going to be backtrack, right? So failed, let's backtrack. So when you backtrack, what you do is, first of all, seeing c will equal to true, will equal to false. Res index will reset to 0, res index plus c will reset to 0. And then we try the next round, right? We try the next one. Which means this can actually be put inside the if clause. We can say if this and this, right? Which just means both are true, and then we have found our arrangement. So we simply return, here we return true, right? We return true. If not, we just keep going until we go through every number, but none of them are true. So when that happens, we'll return false. Right, so that's the backtracking, which I have no idea how long it's going to take. But given that n is only 20, I believe it is possible to go through the whole thing. So now we just call backtrack. We'll start from 0. Oh my goodness. Well, from 0, we have a result, we have a scene, we have an n, and then we'll return a res. All right, let's give this a shot. So this is truly backtracking. It's what's the problem number? 1718. So just pure backtracking. Runtime will be awful. Actually, I never really understand the backtracking. What's the runtime is gonna be? Because I feel you try the first and then you try the second, doesn't work. You can keep going and then you have the backtrack. So like each position can have, technically, each position can have, n different choices, right? But of course, the first one is always going to be the second one. Will have n minus 1, and they have, so maybe it's I don't know, I, I, I don't know, factorial? It's like that. But of course, it's not really n because it's like half deterministic, right? Plus, you didn't even do the edge case consideration here, right? So basically, if I can do that, and I shall say if c is equal to 1, right, we're basically done because you are hitting the last one and it's open. So if that, we just return true, right? That's the edge case. Otherwise, if it's not 1, you have to keep trying. So yeah, I feel like the runtime will be awful, but I guess it's okay because it's only 20, and I think at most is half of them. And not all the options will be handled, but this is not looking good. I have some overflow here. It's probably because I didn't check. Yes, I did not check. So basically, this plus c has to be smaller than rest of size for sure, right? It has to be smaller than rest of size, and then we'll do all the other everything else. Otherwise, you cannot do it. Makes perfect sense. All right, let's run it again. It's wrong. That's very disconcerting. We're putting some position right, but we're missing a lot of the stuff. That's very disconcerting. Hold on, I need to respond to some messages. Hold on. Great. Good message. All right, let's continue. So we definitely have problems. Like this one is not right. I don't understand. We have a rest size is 1, scene 0, 1, and then we start from 0 position, and I start from 1. This is true. Index is, this is true. Oh, this is actually not true. It depends. It depends. Okay, that's actually a good point. Okay, so if c is equal to 1 and res c, no, res index is equal to 0, that is our signal. We say res index is equal to c, then we return true. Okay. Otherwise, we say if index plus c is smaller than rest of size, and this, we don't have to consider this because this has to be considered separately. Okay, let's try this one more time. See how it goes. Okay, we're getting some good. Hold on, let me respond to this message. All right. We gotta write a few, but we got this wrong. How we got this wrong? Oh, because we filled one. I see. Okay, that's actually a fair point. Okay, we don't use this. All right, so let's use set. I think set probably is better because this one I have to go through. Yeah, we have to basically check. Like, we cannot just return true. We do this and then we have to keep going. Then when do we return true? If this is this, then we do this, then we have to keep going, right? Then we have to keep going. We'll return true if everybody in scene, which means we have to go through. Okay, that's fine. That's fine. We'll do that. We'll do that. So basically, we do the same thing. Yes. So if equal to 1 and equal to 0, then we set scene C will equal to true. Right. This will equal to true. This will this, and then we will go through the same thing. How can I do it? Well, this is always equal to 0. So I think that's just if C is equal to 1, right? So basically, C is equal, if C is not equal to 1, I need to know when we need to just move on, right? So we say if C is not equal to 1 and index plus C is larger or equal to rest of size, or scene C, or rest index plus C. These are the situations that we just need to continue. Otherwise, I say, if it's this, then I do this, right? Then I say else if, not else if, it's just else, right? Because I already exclude all the scenarios where we need to continue, right? C is not equal to 1, because if C is equal to 1, we can definitely set that value straight forward. But if C is not equal to 1, and we say basically we cannot find the next position, or we have already used it, right? Or we that position has already been occupied. So any of these, then we continue. Otherwise, we say if it's equal to this, then we do this. Else, then we don't need this entire thing. Oh, what am I doing? Right, then we don't need this entire thing. We can just do blah and blah. And this part, okay, this is the most important part. This part can come outside. We can do it here, right? So basically, this is if we C is equal to 1, we'll set it this way. Otherwise, we'll set it this way. And then we'll find the next index. It doesn't matter if it's 1 or not 1. And I'll call it again. And then I will backtrack. Now I'll try to find the next one. That's perfectly fine. Now, where do we end? Well, we end when we call the next one, right? Backtrack, we call the next one. Oh, because I do that, it will never end, actually. Okay, let's do it this way, right? We do call it, and then I need to know when it ends. So here is how I need to know. I say if I is equal to rest of size, right? Which means the next open position, there's no more open positions, right? There's no more open positions. So now we're just gonna check if every single value in scene has to be has been filled. Well, we just loop through scene and then see if any. So we can say for bool s in scene, right? If we have a false, right? If not s, then immediately return false. So this is a false one. Otherwise, when we handle this but there's nothing, then we just return true. So this is to check. Ooh, I. What the hell is I index? Right, so we use this to check whether we have placed all the values. And then we do the backtrack. Okay, let's try this one. You know, maybe a set will be easier to write the code, that we don't have to do it this way, but I feel this will be faster, but we have an issue. Of course we have an issue, because we didn't check I. Huh. How does that happen? How does that happen? Index plus C is out of range. If index plus C is out of range, I should have already handled it here. We'll say continue. How is that possible? Well, it is possible if C is equal to 1. There's no index plus C. No index plus C, that's true. Damn it. So basically it means that's actually true. When you do the backtrack, it has to be two different scenarios, right? So if C is equal to 1, then we only do, okay, we will do these two for sure. Hold on. So we'll do these two for sure, but this will only do if C is larger than 1. If C is not equal to 1, right, then we'll do this. If C is equal to 1, because I never really said it, right? I never really said it. Okay, let's try one more time. Let's try one more time. Oh my god, this is even worse. What the hell? Huh. Maybe some check was not right at the beginning. Let's see. I didn't even get a 0 right. Oh, nothing gets filled. Okay, that's a different problem. Maybe I just get out immediately. Okay, so I start with 0. Okay, 0 comes in. And then 0 equals to, this is a false, right? I won't do this. And then C is equal to 1. And because C is equal to 1, I don't do this, I do this. So scene, I set to true. And result, 0 I set to 1. I skip both. I do the next. And this basically don't go because it's already getting outside. And I do the backtrack. Okay. I do the backtrack, so this I is already equal to the size of the length, so I equal to 1. So 1 comes in, yes, for all of them, because I already set it to true. So this shall return true, right? And this shall be true, and it shall return true. And I already set the result. Dang it. Okay, I have no clue, so which means we will have to do, it's all right. It's things happen like this sometimes. Oh, oopsie doozy, I did not do this one. What do we do here? So I only need, just do 1. Let's see what happens. Construct, this shall be n. Let's not do the cout. Okay, let's now build again. Cool. Let's come back. All right, just a little debugger. Let's take a look. What the hell is going on? I don't need this. I don't need this. I need all this. All right, let's do F1. Okay, now index is 0. Size should be 1. So this, it does not go. I come here, and let's also get this out. Get this out as well. So for n, oh, because it's 0. God damn. All right, so okay, fine. I know why. Let me exit this. Maybe I should use a set. Okay, so scene 0 equal to true. Okay, so we add this line. Let's try one more time. Man, this is not as simple as I thought. I thought it's just, you know, backtrack. Backtrack usually is not very hard. Okay, now we pass everything. Let's just check if, you know what, dude? We can get everything. Right, we can get everything before submit. 15, 16, 17, 18. Well, that's 19. 19 and 20. All right, I just hope it doesn't time out. Right. I think this is right. Yeah. I think using a vector is making the check. What? Did I miss 11? I have 11. Oh, it only do 8. God damn. I was so confident. Lord. So basically up way to 8 is correct, but the rest is not. Too cocky. I forgot it doesn't do as many. They limited. Ooh, I have 7 cases, right? 1, 2. Oh my god, 11 is the only one that's wrong. You know what we can do? If we're really on the pass, we just say at 11 we return the correct answer. No, we're not gonna do it that way. What in the world? Damn. I'm not sure, honestly. Because that just means when I set 4 here and it just didn't work out. So I put, oh man, 11? I have to go through this 11? Can we just mentally go through this? Well, I'm pretty sure I set 9, right? I set 10, and then I probably set 7 here, but it doesn't work. And I set 6 because 6 is still correct. Then I tried 5, whatever I did, and didn't work. Then I tried 4, which means I tried it, but it didn't work. How would it didn't work? 4, and then what's the next one? It's 3. No, it's 5. So I tried 5, probably didn't work. And I tried 5 and didn't work. Then I shall try 4. 4 is already in, so I try 3. I try 2. I try 1. Okay, I think it's a 1 thing again, right? I try 1, and it worked. Then I move on to the next open position. This is useless. We shall do the debugging. Lord, this didn't take a while. That's fine. We are determined. We are determined. We'll get to the bottom of this. Okay, we'll go through. Wait. No, it's correct. We'll go through, let's just F2 this thing, 2. No, I can't. Oh my god, I have to. Can I step in and step out? Yep, I think I can step in and step out. Let's try that one more time. So I'll do F1, and then I can do F3. Yes. No, it failed everything. God. Oh. Alright, let's just do one by one. It's painful, I know. This is what? This is, you know what? I can. How do I debug at that? I honestly don't know. That is very embarrassing. I shall be able to, right? I don't want to go through everything. No stop thread can now move. Ugh. Hold on, let me think. I didn't know it well enough, the system, the idea I'm using. How? That's a very good question. How do I debug when it hits 5? Well, I mean, just not really, just when it gets 6. I don't know. I feel like I should. I should be able to set a conditional, right? I set a breakpoint which is conditional. Only break, like say, when a certain value equals a certain. Yes, there definitely is a way. I'm very sure there's a way, but I do not know. And since I do not know, we're just gonna go for it. All right, I just go for it. We start index is 0, and then I'll go here, that come in, I go here, that does not go, so yeah. So scene is 11, right? I set them to 11, which is fine. Now I is, go to the next one, so I is, oh, can I see I as well? Yes, I is 1, which is not equal to 0, which is equal to 0, so I jump out, so now I backtrack. So I go in the next one, index is 1, so I go here, the next one I try is, continue, yes, next, so it's 10, so we know 10 is not good, so I try next one, which is 9, okay, C now is 9, and we go here, we set both. Now I set the next one. Okay, inside next is, I'll try 10 again. I think it is 10, right? Next one I try 10, okay. So next I try 10. Now I try 11 first, right? And then I try 10. I go, I set it to 10. That's correct. And I try the next one. I'll backtrack. Now I go through 11, no good, 10, no good, 9, no good, so it's 8, right? We try 8. 8 is no good, yeah, because if it's 8, I think someone gets occupied. Then we try 7. 7 is no good, but really, 1, 2, 3, 4, 5, 6, 7 is no good, so now I try 6. Oh, that's not like that bad. We already arrived at 6. Okay, 6 is good. Then the next one, okay, now we at 5, right? Oh, actually not 5. Now we are 11 no good, 10 no good, 9 no good, 8 probably also no good, 7 probably no good, 6 no good, 5. 5 no good because 1, 2, 3. If I do 5 here, 1, 2, 3, 4, 5. Yeah, 5 no good. So the next is 4, right? I shall be able to give 4. Next is 4. Yes, yes, yes. Okay, we got a 4. 4 is in position, right? 4 is in position. And we do that. Go in. Next one. 10, 9, 8. Oh, 8. 8 is fine. So 1, 2, 3, 4, 5, 6, 7, 8. Alright, 8 is fine, but I think we're gonna have to skip it, but let's have speed later. Okay, 8 is fine, so we set 8 now. Now we go to the next one. That's just 9 is no good. 8 is no good. 7 is no good. Why? 7. 1, 2, 3, 4, 5, 6, 7. Okay, 7 is no good. 6 is no good. 5 is no good. Yeah, 5 no good. 4 no good. 3 no good. 2 no good. 1 is good. Oh, okay, 1 is good. So I set it true, so I get 1. Okay, 1 is only at this position. I go for the next one. So coming in, then nobody is good. Actually, someone might be good. Someone might be good. Hold on, actually, no, I'm not sure. 10, 9, 8, 7. 7. So I can be 7 here. Right? Okay. 7, 7, 7. And then this one has to go a few times when it hits 15. Yep. Now 15 coming in. That's the next one. 10, 9, 8, 7, 6, 5. Alright, 5, I say 5 and 5, but then 4, the next one will not work. Doesn't matter, we go through everything. 8, 7, 6, 5, 4 no good, 3 no good. Now 3, 1, 2, 3 is good, right? 3 is good, but 2 is no good. Yep. Okay, so this is 3 no good, 2 no good, 1. Huh. Oh, that's the bug. Did you see that? Did you see that? That's the bug. We're not supposed to come here. That is the bug. Oh. The bug is when it's equal to 1, I have to check as well. Oh my goodness. Okay, so basically, so if it's equal to 1, how do I say this? If it's not equal to 1 or this. Okay, so these are in the same condition. Oh my god, this is not readable. And we have a or, right? So this is gonna be, what did I do? So this is gonna be C equal to 1, right? And scene C. Isn't that repetitive? So scene C shall be on the outside all the time. Doesn't really matter, right? So it should be like this. If C has been seen, or C is not equal to 1, and I have a bunch of this. So I don't do this, right? Now this looked more right. So yeah, If C has to be seen, like the one we have used already, then we'll always continue. Or if it has not been seen, and if it's not been seen, and if it's one, we can always use it. But if it's not one, we have to fulfill the rest. Okay, let's try this. Let's try this. Yep, that is exactly the problem. All right, let's get all the get the first test cases back. Just want to make sure that everybody still works. Okay, this is good. Wow, that's some debugging. That's some debugging. But definitely need to know how to set a better debugger, like set a better breakpoint. Like we just keep pressing the buttons. This is not good. Yeah, I need to read up how to dynamically set breakpoint in Vim. I do not know. I do not know. I should. All right, it's pretty fast, right? Because it's only I'm not sure about this run time. I don't think so. I don't think it's. I don't know. I mean, they have this analyze complexity. We can actually check. Oh wow, I actually got it right. It is factorial. Okay, I'll give you a thumbs up. I think it's factorial too. Is there a better way? Okay, we do backtracking. Any other way? Nope. I think it is just backtracking. Does the tutorial, not tutorial, this has a better way of doing it. A vector of a vector is number used. Okay, that's exactly the same as how we set it up. This is the result, this. And we call it backtrack, they call it this. That's the starting, like 1, 2. Oh, dang. I guess should just start from, my bad. This is my bad. I shouldn't look through all the scene. You should just go through numbers, right? From 1, 2, 3, all the way to the end. You don't have to go through everybody in scene. That's why I have to add this piece. You know what? I don't like it. I think this one should be more explicit. This shall just be I equal to 1, I smaller than equal to n, I plus plus, and you do if not seen I. And if you do that, you don't have to do this. And this shall still be good. I mean the debugger, GDB, right? No, I mean this is not Python, this is C++. I actually have no idea what debugger did I use. I mean, it's all in NeoVim, so I just follow tutorials. Yeah, I think this is the right way, right? This is the right way. Okay, so what else can you inspire me? So these are the same. And this, if we have filled all positions, are you saying I don't have to do the check? I don't have to do this check? You know what? I think it is right. Why do you have to do this check? Because you are looking for the next, right? You are looking for the next, you're looking for the next I that is good, right? And if everything has been filled, then you're good. Wow, that's absolutely bonkers. Why do you even do this, right? Yeah. Because I'm already searching, right? Every time I add, it's always add at the front and at some place in the back. And after I add something, I always linear search for the next possible position. And when I find the next possible position, I do the backtrack again, So if at a certain point, I search through everything and everybody has been filled, so there's no more position to fill, which means it's already done, which means this is useless. This is useless. Exactly. This is useless. I don't need to do this, right? Absolutely. Okay, so that's that. What else can you inspire me? If the current position is already filled, all right, so this is fine. We don't do it this way because I have this part. So that's a little bit different way of doing backtracking. Doing recursion, that's fine. That's not too big a deal. To place the next, so I target number. They have a target number. What's this target number? Do they even change the target number? No, they don't change the target number. I think they do the same way as I do, just go from the biggest and going down. If it continue, yes. Otherwise, you will put it. Yes, that's what I do. And if it's equal to 1, then you continue do the backtracking, yes. But we try to not repeat ourselves, so I put this logic here, right? And then I don't have to repeat myself. And this is if it's larger than 1, then I need to check yes and make sure it's yes, that's correct. And we place it, then we do this. And once we're done, we will undo the place for the backtracking. Yes, this is basically this part. And they group it inside. Okay, I see. Yeah, it makes sense. And then we undo the other part. Well, it's exactly the same, but that definitely is an improvement. All right, we're gonna submit this one. Let me also write it here. Update. When check for success, right? There is no need to loop through scene to make sure that every number has been used, as long as the next available index has reached res.size, we are guaranteed, right? We are guaranteed to have a success. To have found the sequence. Yep. We submit this to keep a good record. Okay, that'll be it. Good problem. Oh wow, I didn't know. That's actually a good call. I can chat GPT this, right? Sends a signal to the debugger. Well, gotta look into this. But thank you very much for raising this. I never really thought about it. This will definitely help because so usually when I hit, let's say a wrong test case, and debugging this, if it's a small test case, debugging is usually, you can go through the whole thing pretty fast. And if I hit a big test case that fails, I usually have to tweak the test case itself to make it smaller before I can do the debugging. Otherwise, like you have, I don't know, like 20, right? If the array size is 20, debugging usually just as a hell. And I have to trim it down to like less than 10, and then it's debuggable. But if I know how to dynamically set the breakpoint in the system that I'm using, right? If I know dynamically how to set this breakpoint, it'll be much, it will be a game changer. Something to learn. Thank you very much. It's a great idea. All right, that will be it. It took way longer than I had expected, but it's it's not difficult in terms of the method itself. It's backtracking, it's pretty straightforward. We went through a few iterations and we tried a little bit DP. It doesn't seem to be working because I don't see any way to use DP. And we try to find any pattern, but the pattern's just not there. Actually, I don't know if the pattern is there. Well, it's some pattern, but not all, right? And when these two fail, and then I see the biggest number is only 20, which means we can basically use whatever method we want. I mean, the complexity is O(n) factorial, right? So backtracking becomes very viable. And the difficulty is just with writing the backtracking. And honestly, I don't know. It's not really that hard. It's just, I don't know. Maybe I'm making it more difficult than it's supposed to be because I'm doing this, right? I can, like what the editorial said, not do this and then just use the backtrack, use the heap space to do this filter to find the next available position. But I didn't do it. And I also messed up on this. And of course, I also messed up on this. I had too many misses. That's why it took so long. Anyway, that will be it. I'll see you guys tomorrow. Adios.